amines. Amines may be thought as derivative of ammonia. Ammonia, as you know, contains nitrogen and 3 hydrogen atoms. When these hydrogen atoms are replaced by alkyl groups, we get aliphatic amines. So, in my previous class, we are discussing aliphatic amines, which are of 3 types: primary, secondary and tertiary. We have discussed different methods of preparation. Most important out of the methods of preparation is from acid amide. Acid amide general formula is RCONH2. This compound under 2 different conditions. That means if it is subjected to reduction by heating with lithium aluminum hydride or with sodium ethyl alcohol, you will get a primary amine having same number of carbon atom as that of acid amide. This is your acid amide. Same acid amide, when treated with bromine in presence of potassium hydroxide, you will also get a primary amine having 1 carbon atom less than the acid amide. So, this is important, already I have discussed. So, you will also get primary amine. In one case, number of carbon atom remains same. In other one, number of carbon atom decreases. This method is called Hofmann's degradation. Degradation means decrease, Comilla. So far the different properties were concerned. We have discussed it also. Amines are basic in nature. It is a common question. Why amines are basic in nature? Already I have told you. Any organic compound becomes basic in nature when it is capable of donating pair of electrons. The nitrogen atom of amines possesses lone pair of electrons which can be donated, therefore amines are basic in nature. If it is asked prove that, you will write action with hydrochloric acid, also action with sulfuric acid, where you can get salt like ammonia. Ammonia react with hydrochloric acid, forms ammonium chloride, with sulfuric acid form ammonium sulfate. So also all amines react with hydrochloric acid, also with sulfuric acid. Next important was comparison of basic strength. Now remember, when the electron density over the nitrogen atom becomes more, it will be capable of donating easily lone pair of electron, therefore it will be more basic. All alkyl groups are electron pushing groups, therefore theoretically more the number of alkyl groups, that is in tertiary amine, should have been more basic than secondary amine. This possesses lone pair of electron, which should have been more basic than primary amine, which should be more basic than ammonia. This is your tertiary amine. In short, I have written TA, the secondary amine, primary amine. But practically it never happens. It is always found that a secondary amine is more basic than tertiary amine, then primary amine, then ammonia. This is due to, I have told you, due to steric hindrance. Hindrance means obstacle, steric hindrance. Steric word comes from space. Though in case of tertiary amine, electron density over the nitrogen atom is quite large, but incoming group can't reach the nitrogen atom due to the obstacle made by the different alkyl groups in space. So steric hindrance, otherwise called obstacle in space. That was most important. Next was action with nitrous acid. Different amines behave differently towards nitrous acid. Primary amine gives alcohol, where NH2 group is there being replaced by OH group. Secondary amine gives nitroso compound, and tertiary amine gives nitrite salt. Already I have shown it by reactions. Next was your carbyl amine reaction. Whenever carbyl amine reaction asked as a question, underline it. It is only responded by primary amine. Primary amine, when treated with chloroform in presence of potassium hydroxide, gives alkyl isocyanide, which possesses an obnoxious foul smell. So that was most important. So all these things we have discussed. One long question sometimes asked. The question is, write the different amines having general formula C3H9N and write the IUPAC system of nomenclature. Give one test to distinguish between them. I am answering this. Different types of amines you can get from that general formula. This is one. Second, this is second one. Third one will be and fourth one will be. You can see in all these cases, total number of carbon atom 3, total number of hydrogen is 9 and nitrogen. First two are primary amine, next one is secondary amine, next one is tertiary amine. So far UPAC name is concerned, this is propane 1 amine. This is propane 2 amine. This is a secondary one. So this is named as N-methyl ethana amine. This is your NN dimethyl methana amine. You can use nitrous acid to distinguish these three primary. Wherever there is amino group, there will be OH group. This compound form nitroso compound, this will form a salt, nitrite salt with nitrous acid. That part I leave to you. So this is what we have discussed in my previous classes. Today we are going to discuss the aromatic amine. In aromatic amine, the amino group, that is NH2 group, called amino group, is attached to the aromatic nucleus. Here we take benzene as aromatic nucleus. The NH2 group, when attached to it, this compound is called aniline. We are concentrating on this because it is included in your course. So far, the different methods of preparation of aniline is concerned. Let us discuss one by one. Methods of preparation. Some of the methods you will find based on same principle as that of aliphatic amines preparation. Some of them also different. Number one, from nitrobenzene. They are also have taken nitroalkane. There are two methods, bit 1. In both the cases it is reduction, but reduction medium is different. Bit 1, acid medium, reduction. When nitrobenzene is reduced by a mixture of tin hydrochloric acid or iron hydrochloric acid, the nitro group in nitrobenzene is converted to amino group. Amino group, and you will get water. This is your aniline. So this is one method. It is called acid medium reduction since we have used hydrochloric acid. There is another process to get aniline from same that of nitrobenzene is called catalytic reduction. Here we use a catalyst. When nitrobenzene is reduced by a stream of or current of hydrogen gas in presence of nickel catalyst, same reaction takes place. The nitro group of nitrobenzene is replaced by amino group. You will get aniline and one molecule of water. So this method also we have discussed in connection with aliphatic amines. The second method is from chlorobenzene. The statement I am calling you, please note down. When chlorobenzene treated with ammonia in presence of cuprous oxide, formula Cu2O, at 200 degrees centigrade under pressure gives you aniline, where the chlorine atom of chlorobenzene is replaced by amino group. When treated with ammonia in presence of cuprous oxide at 200 degrees centigrade and under pressure, you will get the chlorine will be replaced by amino group. You will get aniline plus cuprous chloride and water. This is your aniline. This compound starting material is chlorobenzene. So this is another method. The third method is from phenol. From phenol. Now, from when phenol treated with ammonia, at 300 degrees centigrade in presence of anhydrous zinc chloride, it acts as a dehydrating agent. We will get the OH group will be replaced by same amino group treated with the ammonia in presence of anhydrous zinc chloride at 300 degrees centigrade. the OH group of phenol get replaced by amino group. This is your aniline, this is your phenol. You should remember there are two different types of substance which takes water. One other is drying agent which takes free water. Already water thibo taku tanno free water. Another is dehydrating agent which takes water which is formed during a chemical reaction. Formed water during a chemical reaction. Here you can take concentrated sulfuric acid, anhydrous zinc chloride are commonly used as dehydrating agent. So this is another method. Fourth one, by Hofmann's degradation. By Hofmann's degradation. Here we take benzamide. When benzamide is heated with bromine and potassium hydroxide, you will get aniline, where you will find the final compound contain one carbon atom less than the benzamide. Benzamide is your CONH2. This is your benzamide. When you heat it with bromine with potassium hydroxide, you will get aniline where one carbon atom becomes less. Therefore, the word degradation is used. Aniline along with potassium carbonate, potassium bromide and water. So you are getting Hofmann degradation method. One carbon atom becomes less. Aniline is a primary amine. The last method to get aniline is by skimmed SSCHMIDT Skim's reaction. By Skim's reaction, we take benzoic acid dissolved in concentrated sulfuric acid is sacked with hydrazoic acid. Its formula is HN3 in chloroform. Remember, ammonia is NH3, hydrazoic acid is HN3. I am repeating, when benzoic acid solution in concentrated sulfuric acid is sacked with hydrazoic acid in chloroform, you will get aniline along with nitrogen and carbon dioxide. This is your benzoic acid treated with hydrazoic acid, Here carboxyl group of benzoic acid get replaced by amino group. You will get aniline plus nitrogen plus carbon dioxide. So these are the few methods of preparation of aniline, which is a primary amine. We have started with reduction process, taking nitrobenzene, the second method from chlorobenzene, third from phenol, fourth one from benzamide, that is Hofmann's degradation process, and the last method is Kim's reaction, where benzoic acid dissolved in concentrated sulfuric acid is sucked with hydrazoic acid dissolved in chloroform, then you will get aniline along with nitrogen, carbon dioxide and water. So these are the few methods of preparation of aniline. Now we will proceed to its properties. Number one, basic character, important. Like aliphatic amines, this amine is also basic in nature, that is basic character. If it is asked why, you will answer the nitrogen atom of amino group in aniline. The nitrogen atom of amino group of aniline possesses lone pair of electrons which can be donated. Therefore, aniline is or aniline becomes basic in nature. If it is asked show that or prove that aniline is basic in nature, you write action with hydrochloric acid, action to prove action with hydrochloric acid, aniline NH2 will form addition compound with hydrochloric acid. You will find NH3 plus Cl minus. This is your aniline. This is your aniline or anilinium chloride, it is called. Anilinium chloride. Similarly, it also reacts with sulfuric acid, form addition compound, NH3 plus 2 molecules here, because sulfate is 2 negative. So this is your anilinium sulfate. So like any aliphatic amines, this aromatic amine, that is aniline, is basic in nature. We have proved action with hydrochloric acid. This you write as B2, I have forgotten to write, action with sulfuric acid. So these two reactions, action with hydrochloric acid, action with sulfuric acid, proves that aniline is basic in nature. The most important part is it is less basic. Remember, question is sometimes asked, aniline is less basic than any aliphatic amine. Question mark, why? Now already I have told you, more the electron density over the nitrogen atom of the amino group, the amines are more basic in nature. If it becomes less, it becomes less basic. In aniline, the aromatic nucleus attached to amino group, that is NH2 group, is an electron withdrawing nucleus. It takes electron from the nitrogen atom of the amino group as follows, and you'll practice these resonating structures. This is important. The nitrogen atom has lone pair of electron which is shifted or which is withdrawn by the aromatic nucleus. So this resonating structure you will have to practice. This is most important, and nitrogen become quadrivalent. Again it is shifted to para position. So you can see the electron density over the amino group, or that is over the nitrogen atom of the amino group, decreases due to electron withdrawing character of the aromatic nucleus. Since electron density over the nitrogen atom decreases, therefore it becomes less basic than any aliphatic amines. Most important, most of the time it is asked why. So the basic character I have completed. Now next we shall discuss action with alkyl halide. Number 2, action with alkyl halide. You have noticed that aniline is a primary amine, so it reacts with alkyl halide, forms secondary amine, which will again react with alkyl halide, will form tertiary amine, and ultimately quaternary ammonium salt. So you take aniline, which I can write as C6H5NH2, or you can write AR. AR stands for aromatic nucleus, or C6H5. When treated with alkyl halide, this is your primary amine. Aniline is a primary amine. So you will get a secondary amine. This is your secondary amine. Again, secondary amine will react with another molecule of alkyl halide, when you will get the tertiary amine plus HX, tertiary amine. As already we have seen in connection with aliphatic amines, tertiary amine again will form an addition compound with alkyl halide, will form ARNR3. There are already two, now another way, plus X minus. This is your quaternary ammonium salt. So this reaction is almost same that of reaction of primary amine, as already we have discussed. Aniline is a primary amine, react with second alkyl halide, form secondary react with alkyl halide, form tertiary amine. Ultimately we will get tertiary amine react with alkyl halide, will form quaternary ammonium salt. Third is action with acetyl chloride. This also we have seen in connection with aliphatic amines, where acetyl chloride react with primary and secondary amines only, because tertiary amine, the nitrogen atom of tertiary amine does not contain any hydrogen atom. So also here, if you take primary amine, that is your aniline, react with acetyl chloride. This compound is your acetyl chloride. In presence of a base, pyridine, because there will be elimination of HCl, to neutralize it we use a base. When you are getting an HCO CH3, the HCl will be produced, which will be neutralized by the base. This is your acetanilide. Next is, this is your action with acetyl chloride. Action with acetyl chloride. Similar reaction will also take place with benzoyl chloride. Benzoyl chloride. So aniline react with benzoyl chloride in presence of same pyridine, which is a base, to form benzanilide. Benzanilide. Let us take aniline. Benzoyl chloride is C6H5COCl. I have written reverse way. Benzoyl chloride, a base like pyridine is required to neutralize the HCl produced to form this is your benzanilide. So with acetyl chloride you are getting acetanilide, with benzyl chloride you are getting benzanilide. Next is carbylamine reaction. Carbylamine reaction. Since aniline is a primary amine, it responds carbylamine reaction. I have told you, whenever carbylamine reaction asks as a question, first write this reaction is responded only by primary amine and underline that sentence. Since aniline is a primary amine, it reacts with chloroform in presence of potassium hydroxide, form phenyl isocyanide. Phenyl isocyanide, which possesses an obnoxious smell. Aniline react with chloroform and potassium hydroxide. You will get remember CN is cyanide, NC. There is a coordinate bond from nitrogen to carbon. This is your isocyanide, phenyl isocyanide, which possesses obnoxious or foul smell. Along with you will get potassium chloride and water. So like any primary amine, it also responds carbylamine reaction, where you can find the phenyl isocyanide is formed. Next is most important, that is sixth one, action with nitrous acid. Why I am telling it is important? Already we have seen different types of aliphatic amines behaves differently towards nitrous acid. Aliphatic primary amine gives alcohol. Aliphatic secondary amine gives nitroso compound, which is a yellow liquid. and aliphatic tertiary amine forms nitrite salt. But here the nitrous action of nitrous acid towards aniline is different. When aniline treated with nitrous acid at very low temperature between 0 degree to 5 degrees centigrade, you will be getting benzene diazonium chloride. This reaction is called diazotization. You take aniline, when treated with, for convenience sake I write NH2 here, aniline. First we treat with hydrochloric acid, when you will get a salt, anilinium NH3 plus Cl minus, anilinium chloride. This anilinium chloride, when treated with nitrous acid, HNO2, you will get benzene diazonium chloride, N triple bond 10. This nitrogen become plus Cl minus. This is called benzene diazonium chloride. There is elimination of 2 molecules of water. So the action of nitrous acid towards different amines is different. Aliphatic primary amine gives alcohol. Secondary amine, aliphatic secondary amine gives nitroso compound. Aliphatic tertiary amine gives nitrite salt. Here you will get a diazonium compound. When there is a nitrogen diazonatom linkage, it is azo word comes. Since there are 2 nitrogen atoms, the name is diazo. Process is called diazotization. So these reactions what we have discussed so far is action due to amino group, reaction due to NH2 group where it is involved. Next we will discuss reaction due to aromatic nucleus, action or reactions due to aromatic nucleus. Now it undergo electrophilic substitution. Now here I am telling you what is an electrophile. Electrophile is either a positively charged ion or neutral molecules having deficiency in electrons and will attack. Attack means react. Attack means react at a place where there is more electron density. जोटी इलेक्ट्रॉन डेंसिटी अधिका थिबो इलेक्ट्रोफाइल विल रिएक्ट. तेणु रिमेंबर इलेक्ट्रोफाइल आइदर positively charged ion or neutral molecules having deficiency in electrons and will attack, means react at a place where there is more electron density. The amino group in aniline is ortho and para orienting group. It is asked why. Since amino group is capable of increasing the electron density at ortho and para positions of aromatic nucleus as follows. It is called activating group, which increases electron density at ortho and para position. You will have to practice these resonating structures. The lone pair of electron over the nitrogen atom increases the electron density either at ortho or para positions as follows. Means you will draw these resonating structures. So these resonating structure is will have to practice. ता नहले परीक्षा लिखि पारिबो नाही. So since electron density you can see increases at ortho position, para position, again at ortho position, therefore the second electrophile will attack. Attack means will react either at ortho position or at para position or at ortho position, depending upon the experimental condition. So if it is asked why it is an ortho-para orienting group, you will write it increases the electron density at ortho and para position of the aromatic nucleus as follows. Then you draw all these resonating structures. We will discuss now few of its electrophilic substitution reactions. Number 1, bromination. Bromination. When aniline treated with a mixture of bromine in presence of ferric bromide, here electrophile is Br plus. All its ortho and para positions are brominated, giving you 2,4,6 tribromoaniline. There are 2 ortho positions and 1 para position. All the ortho and para positions are being brominated to give you 2,4,6 tribromoaniline. However, when aniline is treated with acetyl chloride first, we call it, we protect the amino group. Then brominated, you will get para-bromoaniline. Remember, when aniline as such brominated, gives all its ortho and para position brominated to give 2,4,6 tribromoaniline. But when aniline is, the amino group of aniline is protected by acetylation, then brominated, you will get para-bromoaniline. So if it is as bromination, both these things you will have to write. Now take aniline, treat it with acetyl chloride. As already I have told you, you will have to take pyridine as a base to neutralize the HCl produced. So first you will get acetanilide, NHCOCH3 plus HCl, acetanilide. When this acetanilide is now brominated, acetanilide is now brominated by using bromine. This is brominating reagent, where you will get Br plus. It will only para position will be brominated. You are getting para bromo acetanilide. This compound on hydrolysis, it will give you para bromo aniline plus acetic acid. This is your para bromo aniline. Mark the difference. So whenever it is asked, write about the bromination of aniline, you will have to write two things. When it is as such brominated by using bromine ferric bromide mixture, all its ortho and para positions are brominated to give you 2,4,6 tribromoaniline. Already I have written. However, when it is or when amino group is protected by acetylation, then brominated, you will get first para bromo acetanilide, which on hydrolysis will give you para bromo aniline. Next we shall go to this electrophilic substitution by using concentrated sulfuric acid known as sulfonation. Now, when aniline is subjected to sulfonation by treating with sulfuric acid, forms, first we get anilinium hydrogen sulfate, which on heating between 453 to 473 absolute temperature gives para amino benzene sulfonic acid, commonly known as sulfonilic acid, and this sulfonilic acid exists as deuter ion. Deuter ion means the molecule having both positive part as well as the negative part. So I am writing the steps of the reactions. When aniline treated with concentrated sulfuric acid, aniline with sulfuric acid, it first form an addition compound this compound is anilinium hydrogen sulfate. When it is heated between 453 to 473 degree absolute, you will get an H2SO3H, whose name I have written here. Its actual name is para-amino-benzene sulfonic acid, commonly known as sulfonilic acid. It exists as deuter ion. You can see The molecule possesses both positive part and negative part. One of the hydrogen atom moves to nitrogen, by which nitrogen becomes plus SO3 minus. This is called deuter ion. So, during sulfonation process, we use concentrated sulfuric acid. First we get an addition compound of aniline hydrogen sulfate. When heated between 453 to 473 degree absolute, a rearrangement reaction taking place, you are getting para-aminobenzene sulfonic acid, commonly known as sulfonilic acid. This compound exists as a deuter ion. There is a positive part and negative part. So this is the second category of electrophilic substitution. The last one is nitration. During nitration process, we use concentrated nitric acid and concentrated sulfuric acid. As you know, concentrated nitric acid is a powerful oxidizing agent. Therefore, it oxidizes the amino group to form nitroso compound or nitro compounds. Therefore, it is first protected by acetylation. So, aniline is first, amino group is protected, aniline. We treat it with acetyl chloride. In presence of a base like pyridine, which neutralizes the hydrochloric acid so produced, you will get an HCOCH3 plus HCl. So we get acetanilide. When this acetanilide is now subjected to nitration, acetanilide subjected to nitration, that is by using concentrated nitric acid plus concentrated sulfuric acid mixture. The nitronium ion is the electrophile. The para position is only nitrated to give you para nitro acetanilide, which on hydrolysis will give you para nitro aniline. So during nitration, we first protect the amino group by acetylation, then we subject it to nitration, when you will get para nitroacetanilide, which on hydrolysis gives you para nitroaniline. So during electrophilic substitution, question will be asked why it gives ortho para substituted product. Reason already I have told you. Since it is capable of increasing the electron density at ortho and para positions, therefore the second electrophile means it will either a positive charge or a neutral molecule having deficiency in electron will attack a place where there is more electron density. As we have seen, the electron density at ortho and para position increases, therefore the second electrophile will attack the ortho and para positions. Bromination and sulfonation, last one is nitration. So this is all about the amines. In my previous class, we have completed discussion of the aliphatic amines, and today we have completed aromatic amines, that is aniline. Thank you. Today I am going to discuss the diazonium salt. It is a salt, organic compound having general formula ARN triple bond. When this nitrogen valence is 4, we call it quadrivalent nitrogen, becomes positive charge X minus, which has got similarity with the ammonium salt, say NH4 plus X minus. This is your ammonium salt. It has got similarity with ammonium salt, therefore it is called diazonium salt, where AR stands for aromatic nucleus and X minus may be Cl minus, Br minus, nitrate ion, etc. Negative ion. When AR is your benzene, that is C6H5 here, because one hydrogen atom replaced by nitrogen atom, benzene ring I can write, right? And X minus is Cl minus. We get the compound having formula plus Cl minus. This is called benzene diazonium chloride, or simply diazonium chloride. Sometimes it is abbreviated as BDC, benzene diazonium chloride. So, organic compound having general formula AR and triple bond N X minus is called diazonium salt, which has got similarity with the ammonium salt. When AR, that is aromatic nucleus, is benzene ring, X minus is Cl minus, we get the benzene diazonium chloride, or simply diazonium chloride. Sometimes we call it BDC, in short we write. So far its methods of preparation is concerned, there is only one method. If you remember, in my previous class I have told, by the diazotization process, when aniline is diazotized, we get benzene diazonium chloride. So it is prepared from aniline. Preparation, only one method, from aniline. Aniline treated with hydrogen chloride, excess amount, then with calculated amount of sodium nitrite. When at very, very low temperature, between 0 degree centigrade to 5 degree centigrade, we get benzene diazonium chloride, which remain in solution. So let us take aniline. This is your aniline. When you treat with hydrochloric acid, it first forms an addition compound, NH3 plus Cl minus. We named it already anilinium chloride. Now, we have taken excess HCl. It is treated with calculated amount of sodium nitrite. HCl will react with sodium nitrite, will form sodium chloride and nitrous acid. This nitrous acid will now react with aniline chloride. Nitrous acid will now react with aniline chloride, when you will get benzene diazonium chloride and triple bond NCl minus. This nitrogen is positive, having valency 4, along with the elimination of 2 molecules of water. This is benzene diazonium chloride. In future, instead of writing so many, I will write BDC, benzene diazonium chloride, in short. So this reaction is carried out at very, very low temperature. First aniline treated with hydrogen chloride when you are getting aniline chloride. This on reaction with nitrous acid is prepared at the reaction site. When hydrochloric acid, sodium nitrate react, you will get nitrous acid that react with aniline chloride to form benzene diazonium chloride. It remain in solution. Now, there are 2 different characteristics or properties. In one type, the diazo group is replaced, N triple bond N, we call it a diazo group. So this plus, and we have written some negative part. This diazo group is retained, and in another case diazo group is replaced. So to start with, I am discussing reactions in which the diazo group, that is N double bond N or N triple bond N here, is replaced, replaced or removed. Number 1, replacement by hydrogen. We call it reduction. When benzene diazonium chloride is treated with hypophosphorus acid, hypophosphorus acid, H3PO2 its formula, it gets reduced to benzene, and hypophosphorus acid is oxidized to phosphorus acid. So let us take benzene diazonium chloride. I am writing short BDC. When treated with hypophosphorus acid, H3PO2, it is reduces benzene diazonium chloride to benzene along with nitrogen and hydrochloric acid, and H3PO2 hypophosphorus acid is oxidized to phosphorus acid. So you are getting benzene from BDC, that is benzene diazonium chloride. So here this diazo group is replaced by hydrogen. Next, the replacement by OH group, second reaction. The diazo group can be replaced by OH group. When benzene diazonium chloride added slowly to hot dilute hydrochloric acid. You will get phenol. Diazonium group is replaced by OH group along with nitrogen and hydrochloric acid. So this is your phenol, where you can find the diazo group is replaced by OH group. That is, it gives you phenol. Third reaction in which diazo group is replaced is replacement by chlorine or bromine. We call it Sandmeyer's reaction. Now, when benzene diazonium chloride treated with a mixture of cuprous chloride and hydrogen chloride, you will get chlorobenzene, cuprous chloride and hydrogen chloride. The diazo group is replaced by chlorine plus nitrogen plus HCl. So you are getting chlorobenzene. When same benzene diazonium chloride is treated with cuprous bromide in presence of hydrobromic acid, the diazo group will be replaced by bromine, giving you bromobenzene. So I have discussed three different reactions where you can find the diazo group is replaced. One by hydrogen, second by OH group when we are getting phenol, third by chlorine or bromine, that is otherwise called Sandmeyer's reaction. You can get chlorobenzene and bromobenzene. When benzene diazonium chloride treated with a mixture of cuprous chloride and hydrogen chloride, you are getting chlorobenzene. When treated with a mixture of cuprous bromide and hydrobromic acid, we get bromobenzene. The second category of reaction where reactions where the diazo group is retained. Seti remove houtala, eti rohuch is retained. Diazo group is retained. Sometimes we call it coupling reactions. Coupling reactions. There are two reactions I am discussing under that head. Number one, when benzene diazonium chloride treated with phenol in presence of an alkali, remember alkali or base you are using to neutralize the acid and the byproduct is an acid, you will get para-hydroxyazobenzene, where the phenol couples with the benzene diazonium chloride at its para position. So this is your phenol. The hydrogen atom at para position will react with the chlorine to liberate HCl. This reaction takes place in presence of an alkali. Alkali OH minus will neutralize the HCl produced. So HCl will be neutralized by the alkali taken, and you are getting This compound is para-hydroxy azobenzene. Already I have told you in my previous class, this azo word will be there when there is nitrogen-nitrogen linkage. So, benzene diazonium chloride couples with phenol in presence of an alkali to form para-hydroxy azobenzene, where you can find the azo group is retained. So, this is one of the coupling reactions. Second, number one, you can write action with phenol. Number two, action with aniline. Benzene diazonium chloride also reacts with aniline in presence of same alkali when aniline couples with benzene diazonium chloride at its same para position. When you will get para-amino azobenzene. Here, in presence of alkali, HCl is produced, will be neutralized when you are getting para-amino azobenzene. Same azo group is here, nitrogen-nitrogen linkage is written. So, this is regarding the properties of benzene diazonium chloride. It is a short topic. So, sometimes long question comes. The question comes as write about the method of preparation of benzene diazonium chloride, give one reaction in support, or give one reaction where the diazo group is retained and another in diazo group is removed. So, in removal case I have given 3 examples. So, for retention of diazo group is concerned, I have given 2 examples. So, this is all about benzene diazonium chloride. So, pure organic chemistry course which was given to me, that is compound containing nitrogen. I have discussed amines, aliphatic amine in one class, aromatic amines in another class. Today I have completed benzene diazonium chloride.